Okay, with question 5, we move on to systems that are pairs of quadratics. Okay, and so just like before, we're going to start by solving with a graphic display calculator. So again, I'm using the TI Inspire here, but the process is very comparable to what you would use with the TI-83 or the 84. So the first thing I'm going to do here is enter my equations. So x squared, press enter. Now again, this is a little different because all I got to do is press enter and kind of boom, it appears. And then I come down and ask it to show the entry line. I'm just going to enter the second equation. Okay, and that's going to be x minus 2. Get out of there and square it. Press enter. Okay, and there we go. Now, this is an interesting scenario here. Because this is the same graph, really just shifted over 2 units to the right. And you can see that right there. So these are going to have the exact same vertical stretch to them. Okay, basically in terms of their shape, they're totally congruent. Now, what that would suggest to me is that the only point of intersection you're going to get is this one right here. Now, that'll be borne out when we look at this algebraically. So anyway, so right now I'm going to go down and analyze the graph. Now for most of you, what that was going to mean is you're going to go second trace to get into the calc menu, and you're going to choose intersection. For me, what I got to do is I got to move my little line there to the left of it, and then move it to the right, and then it finds that point of intersection for me. For you guys, for most of you, what you'll do is move your cursor close to the point of intersection and then press enter 3 times. And it'll jump, as long as you've only got the 2 functions in there, it'll jump from one function to the next, press enter, and then if your cursor is at least close to that point of intersection, then your guess is already established here. And I'm just going to grab that, whoops, and pull it down. Well, I can see it actually right now when it highlighted it, I can see it much more clearly. The point of intersection here is the point 1, 1. Okay, so that's what the calculator says. Now, let's solve it algebraically. Well, what I see here is 2 quadratics. They're both equal to the variable y here, which means at some point we can assume that for example in the first equation I can assume that at some point the y coordinate must take on that value, or at least have that relationship there. So basically I can just set these two equal to each other. Okay, at some point for both of these equations here, if they actually do intersect with each other, their y-coordinates have to behave the same. So I can set them equal to each other. And that's only going to work for a very limited number of x's. In other words, this relationship will only work for a limited number of x's. And so now what I do is I solve for that. So now here, remember this is x minus 2 squared. Don't forget to FOIL that out. Okay, that's a huge source of error right here. This becomes x squared minus 4x plus 4 equals x squared. Okay, you have to distribute that out, and then you're going to get the 4 terms, but the two middle terms will be like terms. Now here, I notice, even though it's a quadratic at this point here, it really isn't, because I can subtract x squared from both sides, and I'm left with just this little linear expression. If I bring the negative 4x over and divide, I get x equals to 1. Which is wonderful. So now I've got an x coordinate. I just go back up to one of the original 2 equations, and I'm super lazy and I know that it's going to work in either one of the equations, so I'm going to choose the first one. And if I substitute y into that, y equals x squared, therefore y is equal to 1. And so from here I can see that my point, it has to be, the answer here has to be the point 1 comma 1. Remember the form of the answer, it has to be in the form of a point. It's not enough just to identify that x equals 1 and y equals 1. This isn't the answer, that's the answer. And notice that I'm only getting one answer, okay, which corresponds to what I'd seen before. And again, to check this, I would just say 1, does 1 equal 1 squared when I plug those into the first equation? Well, yes. And then does 1 equal 1 minus 2 squared? Well, let's just think about that. Negative 1 squared is in fact positive 1, so yep, that point 1, 1 works.